Okay, so today's topic is NaughtyMag, and we are going to make this stupid looking MacBook do little bit of naughty things. After a series of rather interesting talks about intelligence, about info stealers, about OT security, welcome to the possibly most boring talk of this entire conference. In case you get bored, you will feel sleepy, please feel free to get asleep. I will not mind at all. Okay, so this is the rough agenda. I will start with basic introduction, basic premise, why do we want to do something like this, and then we will go into nitty-gritties of how to make side channel, what is MagSafe, it's internal, and all that stuff. So this is my introduction. During daytime, I write detections for malwares, exploit, attack vectors. By night time, I write malware. I start basically breaking the security that I was making during the daytime. So I do both sides of security. My favorite pastime is to give shock people existential crisis, make them regret their life choices, and make them question their beliefs around security. And my life motto is basically, let there be malware. If there is some computer involved, some computing devices involved, I want to put some malware inside that. Okay, without that, I won't be able to sleep peacefully. Once I have my malware running, I can wow, now I can sleep peacefully. Currently, I am working at SentinelOne, mostly dealing with Linux side of things, and I am very active on LinkedIn, especially in shit posting there. So in case you want to connect, QR code is right here for your scanning. Okay, typical boilerplate disclaimer, whatever I am going to talk about is strictly for educational purpose only. Don't try to pull this off in real life without proper authorizations in place. Otherwise, you will end up in boiling hot water, and I will not feel responsible at all. That will be entirely your problem. Okay, now comes the introduction part, and the very basic question is why? Why will someone want to chase a stupid looking charging cable which looks something like this, in case you have not seen MagSafe? Why in name of holy C++ someone will start chasing this stupid connector? What purpose does it solve? For me, it was fun. Reason, side channels are very difficult to pull off. So there are very few people who are doing side channel stuff, and the people who do side channel stuff, they get regarded as experts, and everyone is like, oh my God, side channel, meltdown happened, Spectre happened, Plunderbolt happened. How many of you have heard about meltdown, Spectre, and Plunderbolt? Only one? My guys, you need to read some papers on side channel as well. A lot of unholy things are happening there. Okay, so one, side channel is cool. Second, it is difficult, which means that if somehow I am able to pull this off, I get those sweet, sweet social brownie points. I get regarded as haikur, and I want to be haikur. Since I want to be haikur, I do this stuff. And the tipping point in this thing is, see, when I saw this thing blinking, this has a very small LED actually. So when I saw this thing for first time, I was like, okay, this looks interesting. Can I control it somehow? And then I went to Google, did a lot of Googling, turned out that it is possible on Intel Macs, but somehow on that M series, no one has done anything like that. And that is where basically search ends, and I basically forgot about this whole LED stuff. But then there was some PR announcement via by some software company, and that is where I got interested in this again. So before we get to that part, let us talk about MagSafe. So that connector that I showed you, that is called MagSafe, and there are total 5 pins, 2 ground, 2 power, and 1 for communication. It is symmetric, you can connect it both ways. And that center pin, that is adapter sense, that is used for communication between laptop and charging cable and power brick, and by extension power brick and laptop. So all three components are basically talking to each other, and this is not really unique to Apple. There are similar schemes in other manufacturers, laptop and charging bricks, and this is mostly done to figure out basically how much power can be drawn, how much wattage can be pulled for fast charging, or when to stop charging, current regulation, that sort of stuff. So this is not really specific to Apple. The specific to Apple part is that for other manufacturers, that charging cable LED is mostly independent. For Apple, it is not entirely independent, it is controlled by MacBook. So if you have MacBook and you go to system settings, start checking for your hardware information, there will be a section called AC charger information. You will see whether it is connected, not connected, what is the wattage, model number, serial number, who manufactured it, etc., etc. And this information is coming via that one wire protocol, that adapter sense pin, that is the center pin. Now we have already covered this part. This is the main purpose of that particular protocol. And that connector has basically two LEDs, basically two LEDs on both sides. One is green, one is yellowish amber, and it also has a dual channel addressable switch, and addressable switch is basically which can be turned on and off via software. So you can control it via software, and you can either turn it on or turn it off. Okay, so basically software controlled latch, and that is interfaced with LED. So if you want to turn that LED on, you basically talk to that particular addressable switch, and you ask it to turn on one specific switch, and that corresponding LED lights up. So that is what is basically happening here. Now this is the charger setup, how this thing happens when you first connect it. Initially it will provide a very low voltage, basically 3 volt DC, and this is done to keep it safe. So in case you accidentally touch it or something else happens, it does not give you a shock, or it does not get destroyed because of overcurrent or something. When you connect it to MacBook, MacBook will basically apply a resistive load. Basically there will be a resistance connected in series, and because of that you will start drawing some current, but since current itself is limited, as in you can't draw more current than it can supply, your voltage will come down. And the result is that from 3 volt DC, the voltage falls to somewhere around 1.5 volt to 1.7 volt. And charger, the power brick, is actively monitoring this voltage drop. So once this voltage drop happens, that is how the charging brick knows that yes, now the laptop is connected, and now probably I can supply full voltage. And that is when it will wait for basically 1 second, and then it will switch to basically full voltage depending upon exact wattage and model number. It can be somewhere around 14-15 volt to 20 volt for if you have 140 watt charger. Then MacBook will detect the full voltage, and then it will start that one wire protocol to figure out which make, model, serial number, etc., etc. And Apple basically does this to figure out, okay, is this person using legit Apple blessed charger or not? And once it is established that you are using basically officially blessed charger by that I company, then it will start using that input power instead of relying on battery. And the last, it will basically set your MagSafe LED to either green, as in battery is full, or amber, as in battery is not full, irrespective of whether the battery is getting charged or not. Now comes the software side of things, and there are basically third-party software which allow you to control the battery charging, because people are hell-bent on keeping the battery as healthy as possible. So people try to limit it to 80% charging state for most of the time. So they need third-party software to control the battery charging very precisely. And the problem is that these battery charging software will be able to stop battery charging at 80%, but they won't be able to set that MagSafe LED to green. That battery is effectively full for your configured level. And obviously, GitHub issues. There are people asking that, hey, if I have configured it for 80%, why don't you make it green at 80%? For me, the battery is full. And then people were like that, that doesn't really seem possible, until there is one company that makes a software called Al Dente Pro. They released this release. They released a new version, and with that new version, there came the changelog. And they have basically mentioned very boldly, saying that, hey guys, we can make that LED green now. And I saw this, I recall seeing this somewhere on Hacker News, Y Combinator, and I was like, wait a minute. The LED is getting controlled by software. If this software can do it, probably with some effort, I can do it. And if I can do it, let the malware happen, because it is too much fun. From Hacker News, I go here, and then I got this idea again, and then I am back to staring at that MagSafe port that, okay, I need to control this goddamn LED somehow. Little bit more walkthrough over these GitHub issues, and obviously on March 14, right after release of that software, someone mentioned the link that I have no idea how these people did it, but somehow they did it, which means that this thing is actually possible, even though we don't know how it is actually done. Okay. Now, after some more Google foo, a lot of head banging, it turned out that there is no direct API to control LED. Obviously, why will Apple give you that? But this LED is basically interfaced via another component that is called SMC, System Management Controller. And there is a framework from Apple called IOKit, and IOKit can talk to this System Management Controller, and this controller can talk to LED. So if I say the right words to this SMC via IOKit, I should be able to control LED, as long as I can figure out what are those magic phrases. Okay? Now we come to this part, and again this involved a lot of head banging to figure out how to pull this off. So the basic idea is, okay, so I am showing you little bit of code, okay. Don't try to read this right away. I will give you the basic idea what is happening here. Then you can go back, use Xcode, and create a project for Objective-C, and then do something like this, and it will mostly work. So step one is you need to find that SMC device. So for that, this last function call is there. And once you have it, you need to find that device, and then you basically open that device. Once the device is open, you need to basically prepare the data that you want to send to SMC, and there is similar structure if you want to read something out of SMC. The function calls and overall setup is very, very similar. But I have covered only for write part. You can trivially convert it to reading part as well. So there are a bunch of structures that you have to prepare. And then you have to prepare basically the exact data that has to be written, on which particular key it has to be written, and which SMC operation you want to perform. And then you basically perform the SMC write. Okay. So the idea is that in this input structure, you have to specify the data that you want to be written and the key that you want to be written, and that data will be written to that particular key in that SMC controller. And whatever is being controlled by that particular key will have some effect. So this is the general idea. And basically this is the table that you can use for M series, as in from M1 to M4. The key is ACLC. If you have Intel MacBook, the key will be something different. This key does not work for Intel. but only for M series, and these are the values and what sort of effect they will have on LED. So for this talk, I am mostly settling on green and orange part. Reason being 0, 0 is not useful for me because I want the control. I don't want to give it to system. 0, 1 is useless for me because if LED is off and I am trying to record this stupid thing from a camera like from there, I can't really identify where the hell is that LED. It is not very easily visible from that much distance in a video feed. But if it is turned on green or amber, I can find that in video rather easily. So that off part is basically gone. Rest of the things are about blinking, slow blinking, fast blinking, that sort of stuff. Again, that is not useful for me because I want to control the blink as well. So 0, 3 and 0, 4, only 2 values, and then we will figure out how to blink between these two. So this basic premise is ready here. We know LED is controlled. We know how to control the LED. And now the biggest part, how to make data go away out of that LED. Okay, how many of you are already familiar with side channels or have read or heard something about it? Anyone? Yes? Anyone else? Okay, 2. No one else? 3. Okay, so all of you are active in security. You have seen many compromise and breach attempts, and most of the time what will happen that this command and control, exfiltration, all that happen via network. It may be over Wi-Fi, it may be over wired network. It will be over network, and as a result, there are companies which make products and equipments which will monitor at network level or endpoint level to figure out what sort of activities are going on or how if something fishy is happening at some level which should not be happening. The premise of side channel is, if I am going to exfiltrate something and I rely on network, I need to figure out what antivirus or EDR you have, what sort of IDS IPS you are using, what sort of firewall you are using, how you have configured the products that you have procured, and then I have to basically get another copy of same setup, burn a lot of money, and then figure out how do I bypass your entire defense one layer at a time. And that is going to be very expensive for me. You are using CrowdStrike, you are using SentinelOne, someone else is using probably Palo Alto, some other stuff. How many software am I supposed to procure? And how many software am I supposed to reverse engineer and test with? That doesn't really work. So what I will do, I will try to figure out some way to exfiltrate data via some mechanism that is not monitored. And the idea is that as long as you have something, whatever that thing happens to be, as long as you can control it somewhat reliably, you can make a side channel out of it. You have a fancy speaker, probably it can create some noise in ultrasound frequency range, you can make a side channel out of it. You have some sort of mechanical keyboard which you realize that different keys make slightly different sound, so you can put a mic, record the sound of clickety-clack of the keyboard and analyze the sound and make a keylogger out of it. Or probably you can think that, okay, if I somehow stress the CPU, the fan will just start spinning much faster, and you can probably pick up that extra fan noise and make some channel out of it. Basically, all these things have already happened. Exfiltration over fan noise, exfiltration via this keyboard noise, some other acoustic attacks, all these things have happened. The only thing is you need to find something that you can somehow control. As long as you can find it, you can make a side channel. Okay, so for this case, we have only one LED which has only 2 colors. And off state is really not useful because for exfiltration, we are going to record that LED from some sort of camera. Laptop it is at this level, camera is at this level, so off state is useless. So whatever I have to do, I have to figure out using one LED and two colors. Now one can think that okay, it is not very difficult. We have two colors, we have two bits 0 and 1. We can basically say that green is 0, amber is 1, and then based on the bit pattern we can kind of flash these LEDs. But there is a problem. The problem is that if you have a chain of zeros or chain of ones, you won't be blinking that LED. It will be steadily on. And at that state, you need to figure out some way to keep track of time very accurately. And that is a ridiculous problem to solve. And it is that ridiculous that in actual communication channels, you don't have separate clocking. You use something called self-clocking signaling. The signal is carrying data as well as timing both at same time. In case anyone sitting here is from electronics or communication theory background, you will probably realize what I am talking about. So we can't really use this naive method. There is another option in case, okay, how many of you studied computer science in your undergrad? Please raise your hands. Anyone, computer science? Only one person? 2, 3, 4, good. How many of you recall Manchester encoding? That was probably taught somewhere in computer networks. At physical layer communication, where you were studying about OSI, all 7 layers, you start from application, come down all the way till physical layer. And in physical layer, there is some at least one paragraph about Manchester encoding. How many of you recall that? No one? Okay, only one person. Rest of you need to go back and revise the subject. Okay, so the basic idea is that instead of encoding the data at a certain level, you encode it using change in level. So instead of encoding the data in some color, we can encode it in change of color. We can say that if it is going from orange to green, that is 0. If it is going green to orange, it is 1, and then each color state can have same tick length, whatever that duration happens to be. And at absolute worst, we will have same color spanning 2 ticks. That is very much manageable. But there is a problem. The problem is it is way too slow. I will keep waiting forever for my data to come out. I don't have that much time. I don't have that much patience. I need it to go fast, very fast. So there is yet another solution. How many of you are familiar with Morse code? Any ham radio operator here? You probably had to write exam to get certified for that Morse code communication. No one? Okay, only one person. Okay, so the Morse code is basically there are only 2 symbols. One is dot, one is dash, and you encode rest of the characters using some sequence and combination of dot and dash. And if you hear that communication, it will just go like beep, 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 something like that with different length of beep. And that is much faster than encoding bits directly in color transition state. So this way we have to transmit less information to convey same amount of data. So this is going to be faster, so we are going to stick to Morse code. And for this, we can say color green is 0, orange is 1. For dot, we transmit 1 and 0. For dash, we transmit 1, 1, 0. In case you want to insert a space for whatever reason, you can transmit 00. Now the thing is that for timing, you can't have more than 2 ones consecutively, which means that in this scheme, the length of the time length of orange color is maximum 2 ticks, which means that if you record the video and you find what is the longest duration for orange and what is the shortest duration for orange, the ratio will be very close to 2 to 1, and that basically solves our timing problem. So for leaking the data, it is very simple. we get some data, we convert it to ASCII via some suitable encoding if required, and then we convert it to Morse code. That slash is only to indicate that space between hello and world. Okay, and then we convert this Morse code into chain of ones and zeros, and depending upon how we defined 1 and 0, we can keep flipping color in LED, and then we record this blinking from video camera and then do rest of the analysis on video. Okay, so for timing, we already talked about it. The duration for one is maximum 2 ticks, so you can figure out the timing information. You can also do a little bit of sanity checks that you are not getting garbled up video stream. Then for recovering, you need something called beginning of transmission marker. In proper terms, that is called self-synchronization. So again, if someone is from communication theory, you can probably revisit self-synchronizing codes. And if you use something like that, you can recognize that this is where your transmission starts, this is where your transmission ends. And then you basically convert that change in color into ones and zeros, and then you decode in this exact order given. For every 110, you replace it with dash, 10 becomes dot, and then remaining 00 becomes space, and then you decode Morse code. There are libraries to do this. Demo time. So this is my MacBook. You can see that, right? And this is the MagSafe connector and that particular LED, and time to play the video. So this is the stupid stuff I was doing. The LED keeps blinking and I keep getting data out of it. For sake of demo, I recorded via phone by putting it like this. In practice, it will not be that clear, but still, if you have some prior experience with digital image processing, you can do something like either color-based filtering by converting the frames into HSV color space, or you can probably do something like template matching, or if you want to go really fancy, probably you can train your own Haar cascade classifier model for this. But the idea is that this is something that is very easily solvable if you have some prior experience with digital image processing, which if you are coming from computer science and you selected correct elective subjects, you probably already do. Otherwise, this is something that you can pick rather quickly. There are already libraries which do a lot of stuff for image processing, so you can probably use that and do this processing part rather easily. Now we have the video, we have the image that processing part that we run on each frame of the video. So now we know when the LED was green, when it was yellow. We know the frame numbers, obviously we know the timing. So we basically convert this change in color into a sequence of ones and zeros like this, and then we basically change it to this sequence of ones and zeros. And now we do the same decoding part. 110 becomes dash, 10 becomes dot, 00 becomes space. Morse code gets decoded, hello world, and it is basically done. Now there are some problems with this particular scheme. Anyone? Are there some problems with this particular scheme? No one? This is overly visible. You have a MacBook. Your charging LED is just flickering. You are going to go to Google. What do I do? This is flickering between colors. And then you will take it back to Apple saying that, okay, something went wrong. Battery charges, MacBook works, but this stupid thing keeps flickering. And at that stage, my whole attack is busted. Fair enough? So, for that, what I can do, I can go a little bit overboard. I can, okay, this is metal part actually. I can cut this part open, okay, and this has a very thin, a very small PCB. I can get another similar PCB made from somewhere in China, and instead of controlling the LED, I can shove a very small radio transmitter. to transmit this data over radio spectrum. But if I do not want to modify this, because the antenna will be very small, the transmission power will be very, very low, I can modify this and the power brick both. So antenna sits in power brick and it leaks the data over radio waves. And then someone will be like that, wait a minute, yesterday someone was talking about hacking via EM waves. That thing is actually possible. And if someone says that, okay, that radio transmission will look very suspicious, yes, until you go little bit extra overboard to hide that properly. And how you do that? In case you don't remember, at some point of time, an eternity ago, we had market flooded with Chinese EM adapters, which were very bulky, had very heavy transformer to regulate the voltage. At that time, semiconductor based power bricks were not that common because of cost. So if that type of power brick is present and it is not well designed and not properly shielded in some metallic casing, it tends to emit a lot of EMF spectrum all over the place. That is really bad. That is, these were known to be notorious for emitting a lot of EMF wave and basically creating interference with a lot of other equipments. So if you do this via charging brick and keep power low enough, no one is really going to suspect that. They will probably suspect that, okay, my power brick has gone bad, I need to replace it. And if someone says that, hey, what happens if someone has SDR? And he says that, okay, wait a minute, we are seeing this radio emission at this exact frequency. You can hide that as well. Instead of emitting one frequency, you emit multiple frequencies, they get garbled up together and this whole thing becomes noise. And for recovery, you do little bit of math. How many of you hated math in your college? Please raise your hands. Only one person? Two? Rest of you loved maths? Really? So I hope you remember something called Fourier transformation from your college, from calculus, and then if you picked digital signal processing, there was something called Fourier series that gets converted into that Fourier transformation, and in signal processing that gets further turned into discrete Fourier transformation, and then that gets optimized into fast Fourier transformation. So you record the signal, do FFT, get the frequencies, pick your desired frequency, drop everything and recover the data. Little bit of math makes it way more sneakier. Now, countermeasures. You suggest me countermeasures. Let us assume that there is some antenna hidden in your power brick, or maybe this charging cable itself become a long antenna. How will you deal with it? There are two parts. How will you identify something like this is happening? And second part, how will you prevent it from happening in the first place? Anyone? Any answers for detection part at least? Did all of you just give up? Like, okay, I give up, I have no idea what is going on here? Or you have some schemes but you don't want to tell to me with a hope that I will not figure it out and improve this further? Okay, so the thing is, the detection generally becomes very specific to the side channel that you are targeting. So you can't really do much stuff about detecting these. But the general idea is that you should be very, very familiar with your equipments and how they behave under which particular conditions. And if devices start behaving funny for some reason, that will be a reason for you to worry. And then apart from that, for prevention, you have to keep a really tight eye on your supply chain. Because obviously, I will not be visiting your facility saying that, hey bro, I am here to repair your power brick. I will hijack somewhere between your supply chain and basically replace the hardware in middle of the transit. So you need to keep a tight eye on your supply chain and ensure that things like these don't happen. But other than that, there is nothing else to do for you. Thank you, everyone.